Students, in this class, we will see the real numbers, the next part of the real numbers, that is irrational numbers. So, in the last standard, we saw root 2, root 3, root 5 means root 2, root 3, root 5 are all irrational numbers, right? Because they are non-perfect square numbers under the root are also called as irrational numbers. Irrational number has two to three definitions which are not in the form p by q, one definition, whose decimal expansion is non-terminating and non-recurring. That is also irrational number set. And third one is under the root non-perfect square number. Non-perfect square number is also a irrational number. In this class, we will see how do we prove that root 2, root 3, root 5 are irrational numbers, or we say 2 root 2 or 3 root 5 minus 4 or 5 minus 3 root 5 or 1 by 2 root 5 are all perfect irrational numbers. Okay, if irrational number is combined with any other rational or any other numbers, then it becomes a irrational number. Okay, we will be seeing in this class how do we prove all these are irrational numbers. For this, we have to have one theorem here. We just know, see, if p is prime number, if p is prime, p divides a square. See, p divides a square. We'll see with examples. Okay, then p also divides a. Example we'll take, 5 is a prime number. 5 divides, say for example, 25 square. What is that? 625. Yes, 5 divides 525 square. Then 5 also divides the number 25, right? This property we'll be using to prove root 2, root 3, or root 5, or root 11 as irrational numbers. We'll see one by one. I have written here, and we will walk through the steps. This has to be followed in the same way what it is being written here. Okay, the statements should be same. Let's start with root 3. Prove that root 3 is a irrational. This is for 4 marks question, remember, and it is most oftenly asked. I don't say root 3 itself, maybe root 3, root 2, root 5, root 11, like that. Only the number changes here, the rest of the steps remain same. How do you prove root 3 is irrational? So first we assume that to the contrary, that root 3 is rational. Okay, this is the first line. Let us assume that contrary root 3 is rational. When root 3 is rational, we know rational number will be of the form p by q, right? So we write root 3 is a by b for where a and b are co-primes and b not equal to 0. This is the next statement. Because we assumed root 3 as a rational, we equate it to a by b. We say a and b are co-primes. What do you mean by co-primes? Co-primes means they do not have factor other than 1 and itself. Okay. So we simplify it like root 3 is a by b means when you cross multiply it will become b root 3 is a. Right? Understood? Now we'll square both sides. What happens? B root 3 whole square is equal to a square. That means b square root 3 whole square means 3. So 3b square and a is equal to a square. We call this as equation 1. When you say 3b square is equal to a square, that means b square is equal to a square by 3, right? So 3 divides here a square. Okay? 3 divides here a square. We just learnt any number prime p, if it divides a square means it also divides a, right? So in the same way, since 3 divides a square, 3 also divides a. That means a has a factor 3. What do you mean by divisor? It's nothing but a factor. Okay. Since 3 divides a means we assume a is equal to 3c. C is an integer. Substitute a is equal to 3c in the first equation, what we called it as. So 3b square is equal to a square means 3c whole square. That becomes 3bc square is equal to 9c square. We cancel 3 and 9, we get b square is equal to 3 square. Clear? In the same way, 3 also divides b square here, because if we solve for c square is equal to b square by 3 means 3 divides b square. That means 3 also divides b. Here observe 3 divides a, 3 divides b. What was our assumption in the beginning of the problem? A and b are co-primes. They do not have any common factor. But 3 came out now as a common factor. So we write the statement. 3 is a common factor of a and b. Right? But this contradicts our assumption that a, b are co-primes, which we assumed in the beginning. Right? Once we get a common factor, then the a, b are not co-primes anymore. But our assumption was wrong. We write here the statement. So our assumption is wrong. That what was our assumption? A and b are co-primes, or root 3 is a rational. That was our assumption, right? A and b, a by b is a fraction. Since we assumed root 3 as a rational, we wrote root 3 is equal to a by b. But a and b turned out as having a common factor as 3. So our assumption was wrong. So we conclude that root 3 is irrational. Okay. I hope these steps are clear. These steps you have to somehow remember, and you write reason also. If p divides a square, p divides a also, for making 3 divides a. Okay. This is for 4 marks. Then similarly we'll see the root 2. Prove that root 2 is the irrational. Okay. Same steps will continue. In place of root 3, we write root 2. Let's see. The first statement remains same. Let us assume to contrary that root 2 is rational. Then we write root 2 is a by b. Root 2 is equal to a by b, and a and b are co-primes, and b not equal to 0. These conditions should be always written. Okay, you don't forget, right, that condition. Then simplification, we get b root 2 is equal to a. Squaring both sides, we get 2b square is a square, right? I hope you know that squaring both sides. So now 2 divides a square, then 2 divides a. When 2 divides a, we assume a equal to 2c. Okay. When you study this thing with root 3 or root 5 or root 11, just compare what steps will differ here. Then just remember those steps and continue. Every other word statement remains same. Substitute a equal to 2c in 2b square is equal to a square. Then we get 2b square is equal to 4c square. Okay. Upon cancellation, we get p square is equal to 2c square. B square is equal to 2c square. Then 2 divides b square also. So 2 divides b. So we got 2 divides a, 2 divides b also. Therefore 2 is a common factor for a and b. But what we assumed in the beginning, a and b are co-primes, right? So why this contradicts? Because our assumption was wrong. We write that and we conclude that root 2 is irrational. Okay. This is again for 4 marks. We'll move to next question. Root 5. Root 5, also the steps remain same. In place of root 2 or root 3, we just write root 5. Okay. Let's see. We'll walk through this question answer once. Assume that root 5 is rational, then write root 5 is equal to a by b. A and b are co-primes and b is not equal to 0. Then we simplify it, we get b root 5 is equal to a. Squaring both sides, we get 5b square is equal to a square. Then 5 divides a square, 5 divides a. So a equal to 5c, we assume and we substitute in the equation 1, we get 5b square is equal to 25c square. Upon cancellation, we get b square is equal to 5c square. So here 5 divides b square and 5 divides b. How? So solve for c square, we get b square by 5, right? So 5 divides b square means it's a factor of b. 5 is also a factor of b. But we assumed in the beginning a and b are co-primes. But we got 5 is a factor for b and 5 is a factor of a as well. So our assumption that a and b are co-primes are wrong is wrong. So our assumption is wrong. We write that statement and we conclude that root 5 is irrational. Okay. For any single digits like root number and non-perfect square number, these steps remain same. Any number you may take. You can try for 11. You can try for root 7. Try for root 11. Same steps. Our what changes is a equal a here whatever number comes. For example, 7 if you take root 7. Here 7 divides a square, 7 divides a will come. A equal to 7c will come. So we substitute it. Here b square is equal to 7c square will come. Right? Similar ways. These the last steps remain same at all. Okay. We'll see other set of questions along with the irrational numbers, like just not root 5, maybe 2 root 5, maybe 3 root 5, maybe 2 root 3, maybe 3 root 2. How do we prove that? Let us see. Let's take one example. 5 root 3. 5 minus root 3. Prove that 5 minus root 3 is irrational. Here, these kind of questions are very simpler than the previous question. Let us assume first statement remains same. Let us assume to contrary that 5 root 3 is a rational number. Then we write 5 minus root 3 is equal to a by b. This remains same. A and b are co-primes. B not equal to 0. Just solve it here. That is 5 minus root 3 is a by b means I send root 3 to the right side, take a by b to the left side, becomes 5 minus a by b equal to root 3. Means root numbers you separate with the non-root numbers one side. Therefore, on taking LCM of 5 minus a by b, we get root 3 equal to 5b minus a by b. Where a, b are integers, the right hand side becomes rational. Okay. When right hand side is rational, same thing we write. We get 5b minus b is rational. So is root 3. So left hand side also, when we have is equal to right, then the set of things left hand side on the right hand side should be equal. Same category. So root 3 is rational. But we know that root 3 is irrational, right? We write the statement. Our assumption is wrong. So we conclude 5 minus root 3 is an irrational number. Okay. Clear? These steps are very simple. Only thing is you have to separate the root numbers one side and non-root numbers the other side. We say right hand side is always a rational. So is the left hand side. But left hand side whatever it is, now in this case root 3 is always a irrational. So our assumption is wrong. What is assumption? We have assumed that 5 minus root 3 is a rational. That is the assumption. So we conclude 5 minus root 3 is irrational. Okay. You can try for 6 plus root 2 as well. Similar ways. Only rearrangement we have to do in every question. That will be differing. Other than that, the rest of the things remain same. Let's try 1 plus 1. That is 3 plus 2 root 5 is a irrational. Prove that 3 plus 2 root 5. We'll assume as usual 3 plus 2 root 5 is a irrational rational one. We equate it to a by b. Okay, and we solve for root number here. So 2 root 5 equal to a by b minus 3. We transpose 3 here. Then take LCM. 2 root 5 equal to b is the LCM. A minus 3b by b. Transpose 2 to the right hand side. It will come in the denominator. So therefore, root 5 equal to a minus 3b by 2b. Since a, b here are integers, we get a minus 3b by 2b as a rational. And so is root 5 is rational, right? But we know that root 5 is irrational. This statement is very important. No need to prove here again root 5 as a irrational number, which we saw in the first slides. No need. We just make a statement. We know that the root 5 is rational, irrational number. So assumption is wrong. Therefore, conclusion, we do 3 plus 2 root 5 is irrational. Okay, 1 we saw in the previous side, minus 1, and here we saw plus 1. We'll see one more. See, these questions, how many marks? These will be for only 2 or 3 marks, not 4 marks. Okay. Prove that 2 root 3 is irrational. Don't prove root 3 separately now. Okay. So we assume 2 root 3 as a rational number. So a by b we equate it. We write a and b coprimes. B is not equal to 0, which remains same in all the questions. Then we solve for root 3 a by 2b. The root 3 is equal to a by 2b, right? We write same statements. We make same statements. A and b are integers. Therefore, right hand side, whatever we have, a by 2b is a rational. So is the root 3 is rational. Last three statements remain same. We know that root 3, whatever root we have here, as per the question, we write that. When I say same, it doesn't mean root 3 in every question. If it is 2 root 2 or 5 root 3 to 3 root 5, it will become root 5. Okay. So we know that root 3 is irrational. So we make our assumption is wrong. We conclude the answer that 2 root 3 is irrational. You can try for 7 root 5, 3 root 2. Okay. You can write 2 root 5 same ways. Okay. We'll see one more which is in the reciprocal, I mean fraction form. That 1 by, prove that 1 by root 3 is irrational. Similar ways. Let us assume to contrary that 1 by root 3 is a rational. It's our assumption. Let it be rational. Then we at the end make out our assumption is wrong and we come back that given is irrational. So when we assumed it as a rational, we say 1 by root 3 is equal to a by b. In a, b are co-primes and b not equal to 0. Solve for root 3. Root 3 is root 3 into a equal to b, root 3 equal to b by a, right? Or just take a reciprocal of it. Similar ways, a and b are integers here, so we get ab as a rational. So is the left hand side, which is root 3 as a rational. But we know that root 3 is a irrational. In these questions, we have to understand the steps, where to write, how to write. That's very important. It's kind of theory questions, but yet it is important. 3 to 4 marks will come definitely in final exams as well, or even in midterm. Wherever this chapter is involved, this kind of question will definitely occur. Okay, now we say our assumption is wrong. So we conclude that 1 by root 3 is irrational. Okay, we can try for 1 by root 2. Okay, yes. This completes all of our questions, including exercise questions, example questions. Whatever we covered here are all covered and answered. Please go through the slides properly. Make a note of the statements. Try to remember them and write it. Okay. Thank you.